Holiday Lights at Com is back with 3 million lights, new colorful displays, and many of your old favorites. See our salute to active duty military and veterans. For about the price of a movie ticket, you, your family, and friends can enjoy this 3 million light extravaganza with unlimited free carousel and train rides on board the Candy Cane Express. And every dollar you spend at Com stays at Com. Holiday Lights at Com is on Alfred Hale Highway in Northeast Bakersfield between Lake Mig and Hart Park. Just look for the lights in the sky.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at Rosedale Middle School, home of the Bulldogs, and we're here to do the math!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Our phone tutors are here today until 5:30 to take your calls. You can call us here in Bakersfield at 636-4357. Outlying areas in San Luis Obispo, you can call toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online live at dothemathonline.net. And you can look for us on social media at Facebook and Instagram, Twitter, and YouTube.
Well, it seemed like Marylou had quite the cast of characters out there with her. Had the cheerleaders, the mascot, and everything going on out there. And I was wondering if she's going to start doing cartwheels with the cheer team or whatever's going on out there. But we'll visit back with Rosedale Middle School in a little while. First, time for today's Math in the News. All right, well, today's Math in the News has to do with something very, very simple. 1 equals 2.
Really? No, that's interesting. That's it?
Do you have any idea on that? Because I know I didn't talk to you about this at all.
No.
So usually I kind of prep you about what we're going to talk about.
1 equals 2. That's the headline? That's the Math in the News?
Today's Math in the News is 1 equals 2.
Okay.
Can you have any idea how we can do that and incorporate what we're doing with the program today?
No.
All right. 1 phone call equals 2 tickets to Holiday Lights at Com.
Right.
That's how easy it is.
Good job.
There's the information for you right there. All you have to do is call Do the Math this afternoon, and you have to be able to call before we go off the air at 5 o'clock. So there are a couple of people waiting to get on right now. So we'll get to those phone calls in just a moment. But today and tomorrow are the final 2 days where you can call in, do a math problem, and we'll get you those 2 tickets to Holiday Lights at Com. Right now, we'll go to our first phone caller. And Adam, how are you today? Hello, Adam.
Hi.
And you're in 4th grade, correct?
Yes.
All right. What school do you attend?
I go to Logan Elementary.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. My first math problem is 16 times 60. But you have to, what's it called? Round. So 16 would go to 20, and then 60 would stay the same. And then it says choose a method, which I don't know.
Okay, so you're rounding and estimating.
So you're estimating, right?
Yes.
So they don't want you to actually do the multiplication. They want you to estimate this, and then
you estimate the 2 numbers, and then you multiply it.
Okay, so you estimate by rounding off, and so you said, let's make that 16, you're going to estimate that's about 20,
Yes.
and that's about 60, right? And so now this is a problem that you can do in your head, because what are you going to do to multiply these two numbers? Well, we round off because it's real easy to multiply with numbers with zeros, isn't it?
Yeah.
So to do this multiplication, just do it in your head, right? We know 2 times 6 is, what's that?
12.
12. And then those 2 zeros are just 10 times 10, and you can do that very easily, or you can just take those 2 zeros and put them at the end. So I'm not sure what they call this method, but this mental math is very easy with the zeros because you're just multiplying the two numbers and then you're carrying the zeros over. Okay, so is that the kind of problem that you've been doing?
Yes.
Yeah.
Right, and I think what he was saying is he needs to know a method. Like there must be some sort of names possibly in the book
Right.
where they're giving him names of the methods. Rounding to the tens place, I mean, that's not a method. It's, I mean,
Right.
what you're doing. Do you have another problem that's a little bit different than that, Adam?
You know what? I'm on the wrong page. I'm sorry.
Oh, not a problem. Let's get
Okay.
to the right page and we'll do the right problem.
Okay.
As soon as you're ready, let's hear it.
Okay. 73 times 63, and it's the same thing as the other paper.
All right, so 73 times 63, you need to round it,
Okay.
Yes.
and then you need to do it, but then you need to okay, so what I'm asking you is, maybe before all of the problems, like 1, 2, 3, all those problems that you have to do, did they give any explanation? Do they have in bold lettering or something, some names of methods that they want you to use?
No.
Okay, well, let's try this problem the same way. And I know that there are, like Mike said, there are different names for these or different ways of doing it depending on how accurate you want to be and how big the numbers are. When you get into 3-digit numbers, it has another method. So let's go ahead and do what we did the first time. Okay, Adam? We're going to round off. Right? We're going to estimate. What's 73? Well, it's very close to...
3 plus 2 equals 6.
So 73 is very close to 70, isn't it?
Yes.
Right? And 63 is very close to?
70.
Well, but it's a lot closer to 60, unless you're going to round up or round down, again, depending on the method that they want to use. Okay?
Okay.
Well, and that might be the case. It might be round to the nearest whole number, round
And since
up.
right.
I mean, so
And
there could be
sometimes,
some-
because these are both bigger than these numbers, sometimes instead of rounding down, you want them to go up, and maybe you round one down and one up. So it depends on the method that they're having you use in your book. Because again, this problem is pretty easy with 7 times 6. We know that's 42, right?
Yes.
And then we take the 2 zeros. So unless they want you to estimate and give a range, again, I don't know how you've done these problems in class or how you've done them in the book. Sometimes
Well,
they'll have, yes?
It says estimate the product.
Right, so estimate the product, and sometimes you're going to round down and sometimes you're going to round up, right?
Yes.
So in this case, we estimated our product as about 4,200, right?
And if you need a method, I guess you could say something like round to the nearest whole number.
Right.
So maybe that would be one of the methods that you could use is round to the nearest whole number. Significant digits is coming to my mind. Like, all right, if we have 700, larger numbers.
Larger numbers, right.
With decimals, a lot of times with that. Adam, in
Yes.
the directions, it just says estimate and then tell what method you used.
It just says estimate the product, period, choose a method.
Choose a method. So
Choose a method.
I
We-
guess it's
we chose-
whatever one you want to do then.
we chose a method.
So we were trying to think if you had to have certain names for them. But I guess you could just, your method that you're choosing is you're rounding to the nearest whole number.
Okay?
Does that make sense to you?
Yes.
Okay. Well, Adam, that was a great phone call. And by calling in, you've got yourself 2 tickets to Holiday Lights at Com. So we certainly hope you enjoy the program out there. We'll go back to the phones right now. A student from Centennial Elementary School, Derek. How are you? Hello, Derek.
Hello.
What grade are you in?
4.
4th grade. All right. Derek, as soon as you're ready, let's hear the math problem that you're working on.
Number 5.
And go ahead and read it when you're ready.
Susie is an organic vegetable grower. The perimeter of her rectangular vegetable garden is 72 yards. The width is of the vegetable garden is 9 yards. How long is the vegetable garden?
So the width is 9 yards, and you need to know the length?
Yes.
All right. April's all ready to help you out.
Okay.
So, the perimeter
Hello?
of the can you hear me? Can you hear me?
Are you still there, Derek?
Yes.
Okay.
So the perimeter of the,
Oh, okay.
All right. Your mic is not working, so Chuck's going to take over
Okay.
there. So we're going to switch you out on microphones there.
Okay, so we'll get that fixed. Okay, so Derek, we're working with a rectangle. Is that what you said? A rectangular garden?
Yes.
Yes. So let's look at that garden. It's going to look something like this, right?
Yeah.
And we know the perimeter. Now, the perimeter is all the way around. The perimeter, I'll call that P for perimeter.
Yeah.
And the width, see, let's see, this is the width and this is the length, right?
Yes.
So we said the width is 9 yards. I'll just say 9.
Uh-huh.
All right, and we have to find the length. So do you know, how do we find the perimeter of a rectangle? Do you know what the formula is? Have you guys worked with it? Do you know what the formula is?
Yes, like you add all four sides up.
You add up all four sides. So there's a formula using the length and the width, okay? We know that the perimeter, and again, depends on your book, sometimes it's written as length plus width plus length plus width, or it's 2 times the length plus 2 times the width. Do you have that formula? Have they used that in your book?
What?
Have they used this formula to find the perimeter? 2 times L plus 2 times W?
I don't know. I gotta look at my book.
Okay, so they probably gave you a formula to find the perimeter, but you said it's just adding up all of the sides, isn't it?
Yes.
All right, so if this is 9, this is also going to be 9, isn't it?
Mm-hmm.
And so we know that 9 plus this length plus 9 plus that length is going to equal our 72. So let's look at it this way. The perimeter is 72, and we've got 9 and 9, that's 18. And so we have to find out, what do we have to add to 18 to get 72? So what do you have to add to 18 to get 72? How would we do that problem?
9 times.
Now, here's the question.
Well,
right?
he just said 9 times. So my question for you, Derek, is are you doing the area or the perimeter?
How long is the vegetable garden?
Okay, so
But the perimeter was 72 yards,
I was
right?
wondering if the area is 72, we could have a whole different problem
Yeah,
here.
we would, wouldn't we?
I meant it's P equals 2 times L and P equals 2 times W.
So it sounds like he's doing perimeter 2L plus 2W.
Right, so that's the formula
Okay.
we have.
I just
correct?
wanted to make sure we weren't doing area with
Right,
this.
so
'Cause
Derek, we're working with the perimeter, correct?
Yeah.
And the formula for the perimeter is 2L plus 2W, okay?
Yes.
So let me ask you this question again.
Mm-hmm.
What do I have to add to 18 to get 72? Right? What's that missing number? Do you know how you would figure that out?
I don't know.
Well, let's see. I want to find the difference between 72 and 18. So I'm going to take 72 and I'm going to subtract 18, okay?
Yes.
What's 72 minus 18? Can you figure that out?
Yeah, it's 54.
54. Good. Very good. So that's 54. So we know that 2 times the width is 18 and 2 times the length then is going to be 54, right?
Yes.
So 54 is going to be the 2 lengths and 18 is the 2 widths. So that means
I know
that
all the bloopers.
2 times the length has to equal 54.
Mm-hmm.
So here's the next question, Derek. what number times 2 is going to equal 54? 2 times what number is 54?
27.
27. Here we subtracted to answer the addition problem, and here we're going to divide, right? 54 divided by 2 is 27. So that means that this length is 27, and let me go back up to here. This length is also 27. That's an L. So it looks like if I have 27 and 27 for the length and 9 and 9 for the width, those should add up to be 72. And let me ask you again, what was the question they asked in this problem?
How long is the vegetable garden?
And it looks like the vegetable garden is going to be 27 yards long. How's that? Okay. All right. Thanks for the call.
Nicely done. Great problem, Derek. You've got yourself a couple of tickets to go out to see Holiday Lights at Com. Do remember, if you have some other problems like that, we do have phone tutors available until 5:30. Right now, we're going to go out live to Rosedale Middle School, visit with Marylou.
Hi, guys. We are live here today at Rosedale Middle School, home of the Bulldogs, a really special place for me because I get to be here every single day, which I love. And I have two special guests with me. I have Gianna and I have Avery. Hello, ladies.
Hi.
And what grade are you in?
Seventh grade.
Okay, now what do you, obviously this is your first year here at Rosedale. What is your favorite thing about the school? I'll go with Gianna first.
Probably the teachers.
And why is that?
Well, they're really nice and understanding, and they explain things very well.
And Avery, what about you?
Yeah, mine kind of the same, but kind of I like the classes, like, you know, because you get to learn different stuff, you know.
So you like the rotation?
Yeah, because like you get to learn different stuff in school, you know, because sometimes in like elementary school, you know, it would be like, okay, you know, you wouldn't really know when you were going to be done.
Yeah, and this you're very specific. Okay, well, we have a math problem we need to take care of, right? Okay, let's do this work. We have 2x minus 3 with an open parentheses, 4x minus 12, close parentheses, is less than or equal to 4x plus 8. So, Avery, why don't you start us off showing us what we need to do to solve for the variable?
Okay. So I'm going to start by doing the distributive property. So I'm going to take this negative 3.
Go ahead.
And the 3 is negative from the minus sign right here. Yeah, that works, okay. And so then it's negative 3. And then also, before I do anything, I'm going to look over here and see that we have this negative sign, which makes this whole 12 negative. So I'm going to start by just bringing down the 2x. And then I'm going to take the negative 3 and multiply it by both things in here. So I'm going to start with the 4x. So negative 3 times 4x is negative 12x. And then the negative and the negative makes a positive because they're canceling each other out. And so it's going to be plus. And then 3 times 12 is 36. And I'm just going to go ahead and write the rest down. So it's less than or equal to 4x plus 8.
Okay, go ahead, Gianna. What are we going to do next?
Now I'm going to simplify the expression by subtracting 2x from 12x.
So you're combining like terms?
Yes.
Okay.
So I'm going to add 2x. You have a minus sign, so you're going to be subtracting to get negative 10x.
Because obviously we have more negatives than positives. Okay.
And then you bring down the rest of your expression.
Okay, so you've simplified your variables on this side. Now, what do we need to do next?
Now you need to, you're going to make sure that you can simplify your expression more. So I'm going to subtract 36 from both sides.
Okay, do you want, can you also take the 8 away?
Yes.
Okay, so you can do either, right?
Yeah.
Whichever you prefer.
I'm going to do 8.
Oh, okay.
So I'm going to subtract 8 and get 0. I'm going to subtract 8 from here and get 28. Now I'm going to bring down the rest of my expression for x.
And then we have to do 10x plus. So now I see that we have now we get all of our variables to one side.
You're going to add, because you're doing the opposite, 10x to 4x.
Okay, because we want to zero that out, right? Okay. So what we do to one side, we do to the other, right?
10x, you're going to get 0, and then you add 10x here, gives you 14x.
And then we need to bring down our 28 and do our inequality, right? Okay, everybody, now we've simplified it. Gianna has simplified this for us to 28 is less than or equal to 14x. We still haven't found out what x is. What do we need to do here?
So I'm going to take this up here first. So in here, 28 is less than or equal to 14x. And then we have to get the x by itself. And since 14 here is being multiplied by x, we're going to divide both sides by 14, because what you do to one side, you do to the other. And so then 28 divided by 14 is 2, and then less than or equal to x.
Okay.
Or you could also do x is greater than or equal to 2.
Okay, what does that mean? How is an inequality different than an equation?
Well, an equation, you have one specific answer, and it has to be that answer or else it's wrong. But for this one, it could be 2 because of the equal sign.
It could be greater than 2 because that's what that means. Okay, so does that mean that 2 is the, when you say greater than, what does that mean? What does this number x represent?
It represents anything that's more than 2, any number higher than 2, so like 3, 4, 5.
Can you kind of show me on a number line what that means? Okay, just go ahead and you could do it right there.
So do number line, and then you always tell me to do only 3 or 4 numbers, and so I do 3 so that I have a lot more room. And then, so 2 is pretty much our object here, so I'm just going to put the 2 right there in the middle, and then this way to the left is always less, so then 1's going to be there, and then to the right is more, so then I'm going to have the 3 there. And then, so this here, it can also be 2, so we're going to put a closed dot there, and then since it can be more than 2, we are going to put our line going this way to show that it can be more, and then put an arrow to show that that's not where it is.
So it could be 2 or any rational number that's greater than 2.
Yes.
Can it be a fraction?
Yeah.
Can it be a decimal?
Yeah.
Are those rational numbers?
Yes.
Absolutely. Can it be a negative though?
No.
Because why?
Because a negative is less than a positive.
And it's also less than the number?
2.
Well, this is pretty amazing, ladies. Thank you very much. All right, Mike, back to you at the studio.
All right, nicely done, Mary Lou. Let the ladies know that they've also got themselves a couple of tickets to go see Holiday Lights at Com, and they're also entered into the drawing for the 4-pack to go see the Bakersfield Condors. So nicely done. We'll check back in with the Bulldogs of Rosedale Middle School in just a little while. Right now, we're going to go back to the phones. We have a student from Stockdale Elementary, Viviana. How are you today?
Good.
And you're a 6th grade student, correct?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on.
It's 3, then parentheses x plus 4, then close the parentheses, minus 5, parentheses, and then x minus 1, and then close the parentheses, equals 5.
So, Viviana, what do you know about this problem thus far? What should we do? Hello, can you hear me?
Are you there still, Viviana?
Yeah.
All right, did you hear April?
No, I couldn't hear.
So,
Okay.
Can you hear me now?
Can you hear April now?
No.
All right, well, you know what? We're gonna...
Oh, can you hear me now?
Yes.
Okay.
All right, there we go.
So,
Good.
what do you know about this problem? What should we do, Viviana?
You have to get rid of all parentheses.
Okay, and so how do we get rid of the parentheses? We're going to
Combine.
So can
All
I
like
put together, so if I have parentheses here, can I put x together with 4?
No.
No. Okay, so I can't combine that, right? So what should I do? Instead, so I can't combine that. What's happening with the 3 here? What should I do with that 3?
You make it 3x.
I make it 3x?
Yes.
So I'm going to multiply 3 times x, and that's going to give me 3x. Now, do I have to do the same thing with 3 and 4? Do I have to multiply those?
Yes.
Okay, so I'm going to multiply 3, multiply 4. What do I get?
12.
So is that adding 12 or subtracting 12?
Adding.
Okay, so I'm going to add 12. And then what do I do with the 5? And what sign is on this 5?
A negative sign.
So this is a negative 5. And do I multiply the negative 5 as well?
Yes.
So I'm going to take negative 5 and multiply x, and that gives me?
Negative 5x.
And then I'm going to take negative 5 and multiply, what's the sign on 1?
A negative.
Okay, so negative 5 times negative 1 is?
Positive 5.
And then I'm going to bring down the equal sign, and that's going to equal 5. So at this point, what should I do with my equation? Remember the word you used earlier? I should combine?
Combine them.
Are there terms that are...
Combine all the x's.
Okay, so 3x is like, what other term here?
Negative 5x.
Okay, and 3x minus 5x will give me?
Negative 2x.
And do I need to combine anything else?
No.
So is this 12 and this 5 combinable? Are these both constants or numbers without variables?
Yes.
So can I put 12 and 5 together? Can I combine them?
Yes.
So what is 12 plus 5?
17.
So when I combine them, I get plus 17, and that's going to equal 5. We're going to bring that down. And now I need to get x by itself, so I'm going to use the opposite operation. And so I have to subtract 17 on both sides of the equal sign, correct?
Yes.
Okay. So then 17 minus 17 will cancel. And what will I have left on the left side of the equal sign? What's remaining over here? Okay.
Negative,
what do we have left right here?
negative 12.
She's doing the other side for you already.
So I'm not on the right side. Go back to the left side. What do I have on the left side of the equal sign?
Oh.
I'll put what you said on the right side, though, since you already got the answer. So on the right side, I've got negative 12, and on the left side, I have?
Negative 19.
So you're adding negative 2x to 17?
Yes.
So can I put negative 2x with 17? Do they have the same variable?
No.
So like terms have exact same variable. So since they don't have the same variable, and we've already canceled the 17 here, it's no longer there. So if this is gone, what's left? The only thing over there is a negative 2x, correct?
Yes.
Okay. And I have negative 2x equals 12. And then I'm going to, if this is multiplication, negative 2 times x, I'm going to do undo multiplication with what operation?
Division.
So I'm going to divide by negative 2 and divide by negative 2.
And then the negative 2 divided by negative 2 is 1.
Correct. And negative 12 divided by negative 2 is?
6.
And what you want to do is you want to go back to the beginning and you want to
Make sure.
yes.
Let's see if I can move that up there for you.
Perfect, thank you. So you want to check your answer by plugging in 6. So you've got to go 3 times 6 plus 4 minus 5 times 6 minus 1, and you want to check your answer to make sure you're correct.
Okay.
Okay?
Okay.
Do you have any other questions?
No.
Thank you, Viviana.
Nicely done. Viviana's got herself a couple of tickets to go see Holiday Lights at Com as well. Do remember, Viviana and everybody else, if you have some more problems like that, we do have phone tutors available until 5:30. We'll be back with more right after this. Well, today we're in Maricopa. We're at Maricopa Middle School, home of the Indians, and today we're here to Today we're in Maricopa. We're at Maricopa Middle School, and with me right now is 7th grader Leonardo. You ready?
Yeah.
All right. We've got some numbers up here. We've got some whole numbers and fractions. Now, if they were only whole numbers, like let's say we had 0, 1, 2, 14, 28, and 100, those would be pretty simple to put in order, wouldn't they? But we have fractions in here. So we need to put all of these numbers in order from least to greatest. So, why don't you go ahead and read the numbers for us, first of all.
0, 1, 1.5, 5 over 12, and 110.
Okay. So we have 5 different numbers up there, so I'm just going to go like this. 1, 2, 3, 4. So those are where we're going to put the 5 numbers in order. All right? So why don't you go ahead and grab a marker, and how do you want to go about solving this problem?
You'd find out which one is the least first.
Well, out of all of those, what is the least?
Probably the 110.
You think so?
Or the 512, I mean.
Could be.
So the 110 would probably be the least.
1/10 you're thinking is going to be least. I would think that I would agree with you as far as the fractions go.
Yes.
All right? If I have even a part, all right? Let's say there were $10 here.
Yeah.
And I had 1/10 of that. I had $1.
Yeah.
Would I have more than nothing?
Oh, the 0.
There you go. All right. See, that's the thing that I wanted you to see by putting a 0 up there, because some people go, oh, well, it's a whole number and the fraction's got to be.
Yeah, I just remember that.
There you go. All right. So how do you want to start?
I'd put the 0 down first because that's the least right here.
There you go.
So that'd be the 0. And then it would go with the 1/10.
Now, what made you say 1/10?
Because the fact that that's a 1, and then that's a 5, and that's a half. So half would be greater than a 5 and a 1, and that's 1 over 10, which isn't really that much.
Okay, because I know there are some students that are going to be watching, and they're going to go, you know what, but that has a 10 and that has a 2. So why is the 10 smaller?
Because the top number is least than the other two, because that's a half.
Okay, so I'm following you. You're on the right track, right? But they're both the same on top, right? They're both 1s.
Yeah, but that's a half. That's a quarter of something.
Right, that's half of something. That's not even anywhere near half of it. Okay, good.
So then next would probably be the 5 over 12.
Are you sure?
Yeah, 5 over 12.
How do you know?
Because, again, that's a half, and that's just a quarter of what the number is. Or
Well, it's only
a little bit of a quarter.
Right. What would be half of 12?
Probably 6.
Probably, or it is?
Or, yeah, 6.
There you go. Yeah, I'm only messing with you a little bit. All right, so 6 over 12 would be half.
Yes.
So we know, just reasoning, that that's not even half.
Yeah, that's like about 40-ish%.
Okay, so what's going next, you said?
5 over 12.
All right.
And then next would be a half, which would be 1 over 2.
Okay.
And then after that, the greatest number would be the 1, because it's a whole number.
Right. So nicely done, Leonardo. I'm going to have you do one more thing while you're up here.
Right.
Let's go with the half, the 1/2. How would you write that as a decimal? Do you know how you would write that as a decimal?
Yes.
How would you do it?
50.0.
Go ahead and write it up there.
Like, erase that?
No, you can just put it underneath it. So 50, right?
Yeah.
Now, that would be half, okay? How about this?
Oh, yeah.
There you go, because
I
50
forgot.
would be half if we had a whole number of 100, right? But by placing the decimal where you place it, see, there's 50,
Yeah, my bad.
and that's 50 hundredths, 5/10,
Yeah.
1/2. All right? There you go. Leonardo, nice work. Way to go. And one of the great things that they do out at Maricopa is when we went out to visit, I don't know if you noticed, but they had a outline of Disney, Walt Disney, and then Mickey Mouse, obviously, and then inside the school. And a lot of the things they do are on a theme basis. So this year,
Really?
everything had to do with Disney and achieving your dreams and things like that. So they have a lot of lessons, and the whole school incorporates the same theme.
Oh, neat.
So it was pretty neat, because when we went out there, we're like, what's the deal with the Disney stuff going on and things like that. Anyway, we do have phone tutors available until 5:30. However, if you'd like to get yourself a couple of tickets to Holiday Lights at Com, you've got maybe about a few more minutes to call in, because we do have some phones waiting right now, students waiting online. Actually, as a matter of fact, we're going to go to the phones right now from Laurel Glen. Lindsay, how are you?
Good.
And are you in 6th grade?
Yeah.
Is this the Lindsay that was on the program a couple of weeks ago? Were you on the show?
Yeah.
All right, so it's the same Lindsay. That's kind of what I thought it was. All right. Lindsay, as soon as you're ready, let's hear that math problem.
So I'm using percent. So it's George completed 60% of his homework assignment. Write the portion of his homework that he still needs to complete as a fraction.
Okay, so he did 60% of his homework?
Yes.
And so they want how much more he has to do? Okay.
Yeah, the
So-
portion.
Yeah, okay. So if he did 60%, what's all of his homework? What percent is all of his homework got to be?
100.
100%. So how much has he got left?
40%.
Yeah, so that's just 100 minus 60 gives us 40. So he's got 40% left to do, right?
Yeah.
How's that? But they don't want you to leave it as percent, right? They want you to write it as
A fraction.
a fraction. So how do you write 40% as a fraction? What does 40% mean?
40 over 100?
Yeah, so that percent sign actually means out of 100, doesn't it?
Yeah.
So percent is what? Latin, Greek? It's probably Latin, means out of 100, believe it or not. So 40% means 40 out of 100, doesn't it?
Yeah.
And all you have to do is reduce that fraction. They would never let you leave it as 40 over 100, would they?
No.
So how do you reduce 40 over 100? What's the easiest first step?
You would find the common denominator, and it looks like it will be 2.
Well, let's see. I can find an even better common denominator than 2 that is so obvious it's just staring us in the face, isn't it? What number do I know absolutely goes into both 40 and 10? Because they end in zeros. Any number that ends in a 0 has to be divisible by what number?
2.
Yes, but even bigger than that.
5.
And keep going.
10.
10, right? If it ends in 0, it's got to be divisible by 10, doesn't it? So
Yeah.
I could say divide by 10 and divide by 10. But what happens when you take 40 divided by 10? Don't you just lose the 0?
Yeah.
And what's 100 divided by 10? Don't you just lose the 0? So isn't 40 over 100 40 over 10? Now, we're not done, are we? But that was the easiest first step. Now, the first number you said was 2, so let's try that 2. What's 40 divided by 2?
20.
Excuse me, let's go back to 4. 4 divided by 2 and 10 divided by 2, right?
Yeah, so 4 divided by 2 is 2, and 10 divided by 2 is 5.
So it looks like 40% is 40 over 100, which reduces all the way down to, he's got 2/5 of his homework left to do. How's that? Huh?
Okay.
Great, thanks for the call.
Nicely done, Lindsay, and hopefully you have more than 60% of your homework done now with that problem. But if you do have some more problems, we do have phone tutors available until 5:30. Lindsay just got herself 2 tickets to Holiday Lights at Com as well. Have you been to Holiday Lights at Com?
I've been to Holiday Lights at Com.
When's the last time?
2 weeks ago.
Oh, so you've been this year.
This year.
All right, because I was going to say I haven't had a chance to go out this year. What are some of the new things? I mean, like what caught your eye, or like what should people expect when they go out there?
Lights. A lot of lights, a lot of pretty lights. There is a music and light show that I thought was pretty cool. So music's playing and lights are going with the music, and I was entertained by that.
All right, cool. So something a little new, something different. I don't remember seeing the lights and the music
It's
and things.
over by where the kids are playing soccer.
Okay. Well, there you go. Something new all the time.
Yeah.
636-4357 is the phone number. We do have phone tutors available until 5:30, but right now we'll go back out to Rosedale Middle School, visit with Marylou, and see what she's going to put to work.
Thank you. We are back here at Rosedale Middle School, and I am with Kismet. Hello. How are you doing? And you are in what grade?
8th grade.
8th grade. So this is your 2nd year as a Bulldog? Yes. Okay, what do you like best about our campus?
I would say electives and clubs, there's like a variety of them. There's SSA, student council, and then there's choir, band.
Now, what elective do you have?
Choir.
You have choir. Oh, okay. I haven't heard you sing. You'll have to sing for time. All right, but we have a math problem behind us. And there's something special about this problem. Now, I see there's parentheses. We all know parentheses. But there's these 2 lines. Can you explain to us what those 2 lines mean?
Well, those are absolute value, and it's just little lines that tell you that it's not, the answer will never be negative. It's always going to be false. But why? What does it say? If I have, before we get into this problem,
if I have something that looks like this, and this is saying the absolute value of 3, what does that actually mean? If I was to look at a number line, what does that mean? If I have the absolute value of 3, if there's 0, 1, 2, 3, and here's 3, what is it actually telling us? That we're what away from 0?
3 away from 0.
We're 3 away from 0. So even if it's negative, right, we're still how many far away from 0?
3 away from 0.
So that's why it's always a positive, right? Because it's telling us this is how far we are from 0. So we need to understand that before we get into that problem, correct?
Yes.
All right, Kismet, I'm going to let you go ahead and get on with this problem and explain it to us.
Okay, so I am just going to start by simplifying the problem. So right here, it's -1/2 times -1/2 times -1/2
Because of the what?
power to, okay. And so -1/2 times -1/2 is +1/4. And then I'm going to do 1/4 times -1/2. And this is going to be a negative, so 1/8. So now this has become a -1/8. And now I'm just going to do this one, just like how I did the other one. So 1/4 times 1/4 is 1/16, and that is a positive.
Okay, so let's go ahead and put that right there, right?
Yes.
Now, a lot of times this is what students will do. They'll go 1 times 1 is 2. Yes? Have you ever seen that before?
Yeah.
Yeah. Because you see the 2 ones, now automatically your brain is saying 2, right? But again, we're multiplying.
So now I'm just going to do -1/8 divided by 1/16, and so it's just going to turn into actually 1/8 times 16/1.
We do this with
We flip the second number in
we change this to a multiplication sign. And so it's negative 16/8, so negative 2. But since we had the absolute value sign, it's just going to change to a positive 2.
Okay, let's put the absolute value signs on the sides of that. Again, anything, it's really telling us how far are we away, how far at negative 2 on the number line are we away from 0? We are 2 away. Very good. Okay, let's try another one. Times the absolute value of a variable equals negative 16. How are we going to solve this?
So first, I just need to isolate the variable. So I'm going to divide negative 8 on both sides, because what you do to one side, you always do to another. So this cancels out, and this is also negative 8. So b equals negative 8 divided by negative 16 is 2. And so because it was absolute value, it can be 2 or negative 2.
Okay, let's kind of prove that, because we know that the number inside can be either negative or up. So let's plug in this back number and still have the same.
Negative 8 times,
Let's do the absolute value of positive 2.
positive 2 equals negative 16.
So here,
It's just negative 8 times 2,
okay.
which would be negative 16, so that works out.
Okay, now let's do it again, but instead of the positive 2, let's put the negative 2 inside the absolute value.
Okay, so it's the same problem because it has absolute value sign, so it would still be a regular 2. So that would also be negative 16, which also works out.
So no matter what, we always talk about checking your work, correct? And even with absolute value, we still can check our work to make sure that the positive and the negative work out. Very well done. Give me 5. All right.
All right, I saw her hand go up, so I'm taking it that we're all throughout. Now, Marylou, I do believe you have a student body officer that we're going to be visiting with in a little bit?
I just lost you, Mike.
Okay, a student body officer. Do you have a student body officer we'll be visiting with a little bit later on?
Yes, we will be in a little bit. We have our student council president with
Oh,
us
good.
today.
There we go. Student council president. All right, so we'll check back in with Marylou and the Rosedale Bulldogs in just a little while. All right, you ready to work?
I'm ready to work.
All right, here we go. Would you like 1 or 3?
Let's go with 1. I like
Let's
to
go with
draw
1.
right now.
36 gallons of water are poured into an empty tank. Then 3/4 of the tank is filled. How many gallons does the full tank hold?
Okay, so we've got a tank. And then we're going to put 36 gallons into the tank. And when that happens, 3/4 of the tank is full. Okay, so if it's 3/4, that's full, not a good rendition. I'm going to split this into fourths. So this is 1/4, 1/2, 3/4, and then here's my remaining fourth that I need to find. So if I split this into 3, this is going to be 12 gallons. This is going to be 12 gallons. This is going to be 12 gallons. So 12 plus 12 plus 12 is 36. And that means this has to be 12 gallons. So if I have 12 plus 12 plus 12 plus 12, the entire tank is 48 gallons.
All right, nicely done. Thank you for that. 636-4357 is the phone number. We do have phone tutors available until 5:30. I've got a math problem for you guys to work on. All right? Okay. So you go ahead and erase that because you may need to, you can also probably just
Thank you.
mentally approach this one as well.
Okay.
What is the only positive 2-digit number? Okay, so we have a positive two-digit number
Okay.
that is equal to exactly twice the sum of its individual digits. So you have a two-digit positive number.
You have a two-digit number, and you want it to
that
be...
is equal.
I don't think I'm going to make an equation out of this,
No,
am I? Okay.
no, but this might help you out. It's equal to exactly twice the sum of the individual digits.
Sum of the digits.
So it's the only number that will satisfy this.
The only number that's equal to 2 times the sum of the digits.
If you add
So
the digits.
I'm just going to put down a number.
Okay, and
see.
start from there.
Yeah, and see. So 1, 2.
There you go.
12, right? So 12. So there's the number, and then I want 2 times the sum of the digits, which would be 1 plus 2. So that's going to be 2 times 3, which is 6. Wait a minute. Did you just say I want a number that's equal to 2 times the sum of the digits?
So you're approaching it correct,
Yeah.
but 12's not going to be it.
Right, because 12 doesn't equal 6.
Right.
Right? So that's what we had. This was 12, and this is 6, and those aren't the same. Those are not equal. But that was
You're on the right track.
I just took the first 2 digits and put them in there and see, because I don't know what else to do. So I guess I could try the next 2, right? So I guess I'm just going to say, how about, well, 12 gave me 6, so maybe what if I took 24? So that's going to be 2 times 2 plus 4, which is, there's a trick to this, isn't there?
Well, you've got 2 times 6 is now 12.
And still, they're not equal. But interesting that this is twice as big as that, and this is twice as this. There must be a pattern there somewhere. So, April, you want to give me
Any
2
ideas
digits.
there?
Give me 2 digits. We're not getting very close, right? But I want them to be equal. I want these 2 numbers to be equal, and we're not getting
Well, what
close.
if you put an odd number in the mix? Because right now you're just using even
Yeah,
numbers.
I just picked those, like 23 or 47 or something.
Yeah, let's try
All right,
47.
here, I'm going to give you a hint.
We're just doing this.
I
randomly.
know. I'm glad that you guys are going through this. I'm going to give you a hint. Your hint is Alice Cooper.
Alice Cooper.
You're old enough to know what I'm talking about, possibly.
Yeah.
Alice Cooper song.
Whoa.
I have no
okay.
idea.
And Alice
How
Cooper.
about one of the college kids in the back here, an Alice Cooper song? You may not know the song. Yeah, see, the kid, he doesn't know the song. He knows what the number is, though. All right. A boy and a man. At what age are you boy becoming man? Legally.
Well, legally it's 18.
Try that.
Okay. So 18, well, that was that in between. That would have been my next guess, because it's right in between 12 and 24. So that's going to be 2 times 1 plus 8. And 1 plus 8 is 9, so 2 times 9 gives me 18. So we would have gotten there eventually, so it looks like that's the number, right? 18 is the only number?
That's the only number. Now that we've done this, you remember that song? I'm 18 by Alice Cooper?
Yeah,
No,
just barely.
yeah,
Just
a little
barely.
bit, maybe,
I
I
know
don't
a few Alice Cooper songs.
All right.
What are the big Alice Cooper?
Right. Well, it was one of those songs. I mean, it's on the radio all the time if you listen to that classic rock and
Classic
stuff
rock.
like that. So anyway, we'll take a look at this one more time. The only positive 2-digit number, 18, that is equal to exactly twice the sum of the individual digits. So it comes out to be 18. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, our final visit out to Rosedale Middle School. We've got Marylou with all of the guests that were on the air today.
Thanks, Mike. We're back here live at Rosedale Middle School, and it has been so much fun being here today. And I want to thank my 3 guests, Gianna, Avery, and Kismet, for helping out today. Thank you, ladies. You guys have fun? Yes. And there is a treat for you guys. So I have a little prize. There you go. Shirts for you guys. Now, what you guys have to do, though, okay? I know you're in 7th and 8th grade, and fashion means everything, but this is the best fashion statement there is. So you got to wear them to school,
and advertise and let everybody know if they need help, they need to call, what? Where do they go?
Do the math.
Do the math. Exactly. And I have some really special guests here with me. I have
Nathan Connolly and our school principal, Becky Duvall. And now, you guys are here because there's so much happening in our school. We're really a busy, busy school. And Nathan, can you kind of tell us?
Oh, definitely. Our first event that we've done is animal shelter. We've been collecting for the little guys out there in the animal shelter. We've been collecting blankets, toys for them, and even towels, just to keep those guys safe and cozy. Another one is Ronald McDonald House. The Ronald McDonald House is somewhere where the parents go when the child is very ill, who's sick.
And that's located behind Memorial Hospital.
Yeah. And there's another one, Nathan's Wish. What Nathan's Wish is he collects toys for
needy children
and who have very severe illnesses.
Now, Nathan actually was one of my students about 3 years ago, where he passed away from brain cancer, and
he had a wish.
Yeah, his wish for Christmas was to collect as many toys as he could and donate them to the Children's Hospital. And he did pass away that Christmas, and our school continues that wish for him.
And our other one is Red Ribbon Week. What Red Ribbon Week is to aware people of drugs and alcohol and how you can live your life while having fun without drugs and alcohol. And what we did is we had a rally, we had a professional speaker, and we just had fun doing it.
Very good. And Mrs. Duvall, we know we
these are life skills class made for the Alliance Against Family Violence, and it's just a really nice thing to give the kids that are in the middle of a crisis, and they get a nice quilt to make them feel safe. And we have lots of going on our campus. We have a really where we train kids and how to become influencers on campus, and it really helps them become change agents against bullying. Just really making kids feel like they fit in and have a home here at school. So it's been a very, very do lots of stuff. We can't come out and do some. Well, thank you so much for allowing us to come out today. This is cool. And I have a gift for you as well. And it's been great out here today. And back to you in the studio.
Marylou, let all of the students out there know that we'll be sending out their holiday lights at COM tickets to them tomorrow. And they're all entered into the drawing for the Condor tickets, as well as all of the other students that have phoned in this afternoon. Remember, tomorrow is the final day where you can automatically get yourself a couple of tickets to holiday lights. Let's see who's going to the Condors.
Adam.
All right, so Adam from Loudon Elementary, congratulations, double winner. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.